So hello everyone, welcome to join the seminar. So as you may notice that I have taken over to organize the following around the pension retirement and the aging seminar. And thank you for your attendance and the support. Before we begin, we acknowledge the traditional owners and the custodians of country throughout Australia and their continuing connection to land, waters, and culture. We pay our respects to the elders past, present, and emerging, and extend that respect to Aboriginal and Torres Strait Islanders who are present here today. Now, okay. For the online audience, please mute your audio. If you have a question or comment during the presentation, please write question or your name into the chat box. I will then give you a word during the Q&A break. So now let me introduce our today's presenter. And Dr. Alexeev is a senior research fellow at the Faculty of the Medicine and Health at the University of Sydney. He with a master's degree in finance from the Paris Dauphine University, a master's degree in economics from the York University, and a PhD in economics from the University of Technology Sydney in 2020. He leads an interdisciplinary project to improve the field of health economics. As an experienced economist, econometrician, and the trail methodologist, Dr. Alexeev is well-versed in experimental and quasi-experimental empirical research methods. He is particularly interested in health and risk health behavior. So now I will give hand to the Dr. Alexeev to let he introduce his project. Okay.
So today we're going to talk about how the swings in the housing prices may appear as a disappearance of the middle class. So I'll start with making my claims, and then we'll move to my, to the guts of the paper, to the arguments, and then at the end we can have some space for kind of big implications of this finding, some speculations. All right, so the empirical literature on the distribution of economic outcomes conceptually should use economic income as a measurement. In practice, however, disposable income is used. And it is well known that this practice might misrepresent the standards of living because economic well-being depends not only on monetary sources, but also on non-monetary sources. So these examples of three of them, such as public education and public health. But today we're going to talk about one of them, about imputed rents. Let's just to foster better intuition, consider a case. There's a village where farmers grow their own food and exchange it, reserving money for occasional city visits. So if you disregard the non-monetary and economic well-being derived from own grown food, you will never be able to correctly understand the standards of living and compare them across subpopulations or across time. So food is quantitatively negligible for developed countries. But what's not negligible is housing. And again, consider another riddle. So there is two individuals who have the same disposable income. However, one owns recently purchased state-of-the-art $1 million house, and the other lives also owned in a granny house, which requires constant maintenance. So if you only look at disposable income, you'll conclude that they're equally well off. However, but their actual well-being is very different. And the traditional and convenient income measures, they completely ignore this fact. So yeah, the solutions is to, if everything was provided through market sources, for example, if in the village all the farmers were buying everything from the market, we wouldn't have any problems with that because everything would be accounted for. And the same with if everyone rented their housing, we wouldn't have any problems because we can simply, subtract the rental. But the problem is that because the fraction of people who own their house and derive those benefits from owning house changes across population, across places, and across time, it might cause comparability issues. And so the way to do this is you have to quantify these benefits derived from home owning and add it to income. That would be the correct way to do it. So far I was trying to convince you about the existence of imputed rents. So now about the paper. So please look at the left figure shows you the Australian household income distribution, and we want to look at the blue line, blue solid line, and the yellow line. Sorry, blue line and the green line. And you can see that, so this is income 2001 and 2007. And you can see that over the 7 years, household income distribution, Australian income distribution developed a notch. There's an obvious notch here. And the figure on the right suggests the explanation. You can see that from 2001 to 2007, there has been a massive increase in housing prices. And so again, so owning a home is essentially like running its own business. And to wait to see those running its own business that generates profit. And one way to see those profits is to acknowledge that those who do not own homes, they have to pay money to get they have to pay rent. And so conceptually, this rent has to be, the imputed rents, the benefits from home owning has to be included into income. However, in practice, imputed rents are disregarded because there's a very large literature that shows that when you include imputed rents and try to measure income inequality, it has no significance. It makes no difference. But I will show in this paper, I will show essentially 4 things. I will show that that this existing literature has paid attention to the wrong part of income distribution, whereas inequality looks at the tails of distribution, and indeed I'm showing that IR does not affect tails of distribution inequality, but it has a massive effect on the flatness in the middle, which is an income class. And I also will show you that this effect of IR on polarization measures is mediated through housing cycles. Essentially, the story is like this. So we got this, income looks like this, looks normal. Then we have spiking housing prices, and that's what caused this reduction, this nudge. So we're going to use 7 years, 7 years for 4 countries. That's the data we use. That's the summary. I'll let you reflect on that for 3 seconds. Okay, now I'll move on. Yes?
You're ignoring the capital gains.
Capital gains. Capital gains. So capital gains derive from housing prices increases. This is perhaps so. This is about perhaps this would go into the wealth, measuring on the wealth. Would you agree?
Yes, and it has a knock-on effect on spending.
Well, I guess so. Okay, let's agree on what do we want. Well, this is a really good question. It's a tricky question because we have to kind of talk a little about what do we want from income outcomes. And the agreement, so economic outcome is everything that affects current consumption and your standing in the future within the allocated period. It's not capital gains. Yeah, right. Oh, no, I do not do that. Sorry. This is such like a question. It's a very good question. I presented that once. Nobody asked that. So I'm using, at the baseline, I'm using a disposable income, which is given by SNEF, across, the one that's comparable. So, and they do add everything. So they use disposable income in this kind of, in this very wide definition. I think they include that. So effectively, but we'll talk more about this just in a second. Yeah, but that's right. So capital gains. So okay, so let's drop all my rambling. Yes, I include that. Yes, it's there, and thank you for pointing that. Alrighty. So okay, let's go. The methods. All right. So measuring rates. So imputed rents is conceptually it tries to capture the stream of benefits derived from home owning, and so it's not easy to actually assign that. There's no universal method to assign a value to this stream. And so there has to be, for example, if you look at the Switzerland where they actually tax imputed rents, each canton, each territory used its own method. So it's highly institution specific. But in general, they distinguish 2 methods that generally distinguish. One is called the comparison method, and when you compare the same property to the same property rented out. And so the kind of a sciencey way to do it is to just use a hedonic regression, which is just takes the database of recently rented property prices, and then you regress the rental values on the characteristics of the property that sort of the coefficients in this regression captures the preferences for those characteristics on the market, and then you make an out-of-sample prediction, and then this is how it's done. But this method works well when there is very low home ownership rates. Yes.
I'm just wondering, historical regressions usually are about like physical characteristics of the house and the property.
Yeah.
How do you account for the difference in quality? So you can have a 3-bedroom house that's kept in really good maintenance and one that's run down.
So you're talking about unobserved. So okay, in this regression, so yeah, this was coming up just next sentence. So okay, so this is just what's used in practice. And hedonic regression, it's neat, but like I said, so essentially the assumption of this regression to be valid is that the properties which are rented out, they're rented fairly random throughout the stock of market. It's a strong assumption. For example, in Sydney, nobody ever rents out the castles in the eastern suburbs. So essentially, it kind of, if you do not have a randomly selected properties, then you might have the kind of Hackman-style incidental truncation problem. Again, in those ambiguity about the functional form, because what's liked in one market may not be liked in the other. So this is sort of a drawback of this method. So you need a lot big data, low home ownership rates, and you have to kind of have a consensus about the functional form. So, but that works in the continental European countries. For example, Germany and Switzerland, where most people actually rent their houses, nearly most in Germany. So in countries where the home ownership rates are high, people love their housing, like America, Australia, so hedonic regression is not going to deliver you a very reliable estimates. Therefore, what's used is just the cost of home owing, which cannot be recovered. So interest rates usually captures kind of the cost of capital and the profits of owing home, and user costs include depreciation, local tax, stuff like this. So, and it's also kind of country specific. So it can, because all the taxes are country specific stuff like this. Alrighty, so okay, this is rent. But so in practice, I'm using the rents. So imputing rents it's an ambiguous exercise. But so what I'm using, I'm not doing that. I'm using what is raised in the data. I'm using data custodian IRs. But even then, I'll show you I'm using country fixed effects, and as long as IR is consistent across the time period, it should not matter, the differences across countries. So this is measuring polarization. So I'm using a standard ER index. So ER index, it's a generalization of Gini coefficient. So essentially, so you choose A. So so this is the expression that takes a distribution, spits you a number. So if you pick A as 0, you get Gini coefficient. If you ramp it up to 1.6, then instead of Gini coefficient, you capture the movements in the middle of the income distribution. And so what's happening? So the following, so the map of the methods is like this. So I've used this. So I have 4 countries, 7 years. Then this ER index, so measured which include IR and do not include IR. And I have ER index ER, which if it's 0, then it's inequality. If it's 1.6, that's polarization. So I have a country level panel where values vary by country, year, IR, ER. And so this is what is used in the analysis, in the baseline analysis, much more analysis than that. All right, so I take the data set and then I use this two-way fixed effect regression. So what we want to get, what's the answer? So the question is, does including IR changes the measured index? And so this can be done with this regression. So D is your dummy. So you have a panel which includes IR, does not include IR, and you want to see if they differ, And so you can do this with the dummy. So dummy on the measures where IR is included, and this coefficient will show you if there's a difference. Like I said, so the country fixed effects are important here because they account for the potential ambiguous definition of IR across countries. So, and then sort of as just a little just foreshadow the results. Is that the word? Foreshadow the results. So I'll show you that, as sort of one might reason, is that the IR affects polarization because polarization is about middle class, and this is where transition of home ownership is most likely. So it affects polarization, but does not affect inequality. And we'll build on this. That's contribution number 1. Contribution number 2 is that, so because, IR affects polarization, but not inequality. but we would like also to link that with housing cycle. And I will use this triple difference design to show that the effect is mediated by the housing cycle. Okay, so there's 3 levels of contrast. So we use later stage of the cycle, more intense, against earlier, weaker stage of the cycle as contrast 1. Contrast 2 is measures which are include IR and exclude IR treatment contrast. And the other contrast is, this is a later, earlier stage. So this is included, not included IR, and this is A, is that because I will show you that polarization is not affected, but inequality affected. This is the third contrast. So okay, I don't know, so you should think Wooldridge, everyone should have this guy in their mind. So think about this as like a textbook example from Wooldridge. So you have 2 states, and the policy affects a state, like, you know, elder people in the state. So the same thing here. So kind of the elder people is IR measures within the group, inequality in a state. Hold on, it's after. Anyways, it works somehow. I don't know. If you have any questions, we can talk more about this. I don't know. I'm just going to assume that kind of clicks. All right. Yeah, I would welcome questions now rather than later. All right, it's fine. Alrighty, so I'm done with methods now. Now data. So what is actually used in SNF? Oh, we're doing really good time-wise. So what is actually being used in SNF? So again, SNF is the, what's it called? It's a cross-national equalization file, equivalent file. So this is a project where they take the national household surveys and they make them directly comparable. Particularly in disposable income, they do a really good job with disposable income. But some of the panels also include IR, imputed rents. Imputed rents are not explicitly made comparable. Again, and this is not a drawback. It has to be institution-specific, so it has to be country-specific. All right, data. Okay, so what are actually in the SNF? And so this is sort of like a little validation exercise. So I'll compare IRs with home ownership. All right, so United States, what they use is that this is, so they use cost method, and PH is the housing prices now minus remaining mortgage principal. So this is kind of like a fraction of the value that you own, and 6% of that includes, if you remember in the cost user method, it includes interest rate, cost of capital, kind of profits to home owning, and all those local taxes and maintenance. Australian panel combines method. It uses user cost method, so the same idea for owners, but instead of 6%, they use 4%, so it's less. But they also, because in Australia there's a lot of subsidized property, they also do a good job understanding how much the market price would have been. And then the imputed rent for those who live in a subsidized tenancy is the difference between what they would have been, what they should have been paying if it was in the market, minus what they actually paying. For continental European countries, they use hedonic regression, and it's very similar. The procedure is similar, except the equation, the functional form, the variables selected are different. Again, that speaks to institution-specific necessity for institution-specific methods. So what kind of stands out for this method is that, all right, so they use hedonic regression, and then they subtract the cost of owing. For subsidized tenancy, it's just like with the Hilda, it's just how much the market would ask for the property minus how much actually taken. And so one thing about this is that actually if the costs exceed the income, then for these countries, 0 is assigned. Alrighty. Okay, so these are the fraction of so this figure shows the fraction of individuals with positive imputed rent. So this is the column which looks at the home ownership rates just from other sources, from alternative sources, and this is from the data we use. And so what we want to look at, because imputed, so we want to kind of get the ballpark where the imputed rents make sense. And they make sense because when you look in America, if you remember for American data, they do not use, they do not assign any IRs for subsidized tenants. and therefore home ownership rate and the share of population with positive IRs is the same. For Australia, it's slightly higher because we also include subsidized tenants, and for Switzerland, it's lower because a lot of people have, I guess the imputed rent is higher. Sorry, no, the costs are higher than the imputed rents. That's the reason for that. So they assign a lot of zeros for them. But what's interesting again. So there's also kind of another thing which this big figure shows is that the methods are correct in the sense that so hedonic regression works well when you have low home ownership rates. And that's correct. That's valid. That is true for continental European countries. But for Anglo-Saxon countries like Australia, the home ownerships are really high, and therefore you kind of have to use a user cost method. Anyways, okay, so this descriptive statistics. So again, we use 4 panels, and then we kind of reduce those 4 panels into those indexes that we work with. And so this is the descriptive statistic of the kind of individual level data. So here, the only thing that is interesting is so this is the imputed rent, just the description of imputed rent. This is the income, which is disposable income, taken from SNF. So it includes everything but IR. So this is kind of the best way. So SNF disposable income is probably the best measure of income you can get, especially for cross-country comparison. So this is IR imputed, by custodians, income imputed by created by the custodians. So this is the sum of this plus this. But what we really want to look at is the ratio of IR to income. And so one thing to note is that for Australia, the ratio of IR to income it's so high. It's staggering. It's 31%, whereas for Germany it's 6%, Switzerland it's nothing, 3%, and for America it's 18%, almost half of that. But also remember that it only takes so for IR for America we take higher fraction. However, we still get smaller IRs. Results. So I only showed you kind of like the baseline, this kind of regression-based evidence. But we'll kind of start it slow. This is just okay. So this is the effect of IR on the distribution. So we can see that if you saw that picture, and you can see, looking at this, you can sort of predict what's going to happen to analytical measurement of indexes when you include IR. And you can see where Australian values are so high, and they always shift distribution non-trivially. For Switzerland, the distribution practically never changes. United States a little bit, Germany a little bit. But again, so the problem with this approach, we cannot just make conclusions based on that because it's a density estimator kernel, so it's sensitive to kernel and the bandwidth and the width of the bandwidth. And therefore, it's much more interesting to look at the not on the effect on distributions, but on the effect of individual households. And so this is the income group transition. This is a method borrowed from income mobility literature. So okay, let me tell you what it shows. It shows you how, for example, what's your relative position in the income distribution when your IR included or excluded. And so let's look at a reduced kind of table. So this says that so we take IR and divide it into 3 tertiles, and then this is without income without IR, and again by 3 tertiles, and then we take cross tabulation. And so what it says, for example, those people who, when you include IR, those people who are the richest. So for example, okay, sorry. So if there was no effect, if, for example, imputed rent can, let's just forget about imputed rent. It's inconvenient, forget about this. If we could have done it if all of the values was concentrated in domain diagonal. So if your position does not change, if 100% here, so you were low without IR, you're still low when you have IR. And then you go like this. So if you're still middle income, so conclusion 1 from here is that no, we cannot. It has non-trivial effect on position of individual households. Second conclusion is that the effect is concentrated in the middle, not on the tails, at the edges, as the previous literature has been looking at. It's not inequality, it's polarization that is most effective. And for example, okay, so let's look. So those with IR, when IR is included, if you're the richest guy, when the IR is included, so 90 of those households came also were the highest when IR was excluded, but about 10% came from the middle income households. And for example, and those who are middle, so 11% were poor, but became middle income. Right, so and this is sort of, again, so transition matrices are really nice because they make no assumptions on data. So, and this is basically a universal pattern, is that the effect is most concentrated, and so the cells in the middle are the most affected relative to the elements at the edge, at the tails of the diagonal, and it sort of got worse because of the cycles kind of made it worse. So there's even more individuals washed out from the middle. Alrighty. Well, I guess what's interesting is that, or not, I don't know. Anyway, so what's interesting is that, we want to see what are those predictors, who are those households that move? So this is a very kind of predictive exercise, and I hope it's interesting to you because you have retirement in your seminar series, and I actually made this for you. So, okay, so what we can do, so what I've done is this. I defined this kind of household measure of change between ranks. So you take your income without IR, you rank all households, and then you rank them again in the other distribution and take the difference. And so what predicts those differences? So what's interesting is this, is that, so when you look, and so this is using spline regression, so it's extremely flexible, so non-parametric. So because we want to kind of, because it's predictive in nature, not causal, but we want to kind of appreciate all the patterns here. All right, so schooling is ambiguous. So sometimes, for Australia, yes, you would move higher when IR is included if you're educated, and at the expense of those who are less educated. So the question is fine. Yeah, okay. So all right, United States. For United States, it's sort of ambiguous. It's you see, so this is positive, this is negative. So this is all negative. So education kind of protective from moving you kind of. So it kind of it's protective from moving you downwards. Anyways, it's different. So you can sort of, in the paper, I discuss it in detail, but it's probably not working very well. So, but what's really consistent across all the countries is that the people who, if you include IR, the life cycle, the older people always move up in the income distribution, whereas younger people always move down. So for example, in a hypothetical scenario where you would like to tax IR, as some countries do in Switzerland, then what would happen if you assume, again, budget balancedness, yeah? So you would probably gonna redistribute tax burden from young people to older people. Alrighty, so this is okay. So this is again. So this was just sort of this is non-regression based evidence. So now we'll look at the regression. So if you remember, we take those national panels and we construct indexes, and these are the indexes which will be used in regression in a second. And so what stands out again? So none of the measurement really changed much except for Australia. For Australia, okay. So the left figure shows polarization, and they all. So there's no change. For Australia, there's change, but it's uniform change. For Australia, polarization measures, they also fairly unchanged, except for Australia, they're much higher and they jump around a little bit. So this is the data which is used in regression. This is the country level estimates of polarization, which is used in regression. All right, so again, so what's interesting here, okay, so we can look at them like this, but we also can rank countries by the inequality in polarization. This is, in welfare economics, this is a fairly standard exercise because we want to learn, we often want to know what is the most unequal country or the most polarized country. So when you do not have IR, all right, so the top is the Gini coefficient, this is the polarization. Okay, so when you do not, so okay, here at the top half of the table, the ranking does not change at all. And that is what literature has been showing. Inequality has no relevance in ranking. It has very little effect on things. But polarization is affected quite a lot. So for Australia, so it's still, so hold on, when it's high, polarization is high, it have less middle class. So Australia is the, anyway, so it's basically, you can see that this, so when the polarization is high, then you have less middle class. You cannot kind of detect it. So you can see that numbers jump around. So Australia sort of becomes the number 3 and then becomes number 2, number 1. But when you include imputed trends, it becomes much more stable. You only will have one reversal here. Okay. Okay, cool. So this is sort of a parsimonious evidence. So I just showed you so much different things, which kind of suggestive of the result. And this is just a regression based on get one coefficient, and presumably that's what all we want to get. So okay, okay. So this is table number one. So you look at them like this. So you look at them like this. So this effect on inequality, no effect. All right. So let me just explain. So with this from the inference perspective, so it's challenging setting because. So just from an inference, okay, so when you do inference, you get yourself like a variance covariance matrix. And so when you don't have any autocorrelation or clustering, you only have variance covariance on the main diagonal. And that's all the heteroscedastic consistent variance estimators. They allow for arbitrary values on the main diagonal. And so this is, when we do that, this is, so when we apply this variance covariance matrix, we see that there's no effect on inequality. There's an effect on polarization. And so when you take the ratio of this to the mean, you can see that the effect is both statistically significant, it's also economically significant. And so this is when you have a triple difference design. This is which leverages which tries to link the housing swings to the effect of IR on ER. Why it's important? It's important because, for example, it means that we can use disposable income if we excluded housing swings. You know, so there's a way out of this whole problem. If you just before you kind of use, if you want to use disposable income and you want to use that to compare countries, so subpopulations, so across time, across locations, just make sure there is no housing swings, price and housing swings. That's that. So there's a way out of this problem. And this basically shows that. So the effects are correct. The effects are correct. So you get. So when you use dummy, this is the baseline with the model which I presented. But you also, it's because when you use this kind of separation, later period, earlier period, it's potentially arbitrary. So you can actually specify a triple difference, like a dose response, where you kind of 1, 2 is like a year of the cycle. So it's so the idea that exacerbates over time. So the treatment here is like 0, 1, 2, 3, 4, 5. Either way, the effect is present. All right, this is used when you use GLS. So GLS is because so I mean what the mathematicians do a lot today is that they use cluster robust inference, but it's inefficient, it's known. So because it needs a lot of data. I don't have much data. So another way to go about this is to allow for clustering data, autocorrelation on this stuff, is to use GLS. And so in this case, so GLS, when you assume that the elements are inversely proportional to the sample of the underlying panel data. If you remember, because estimates are subject, the estimates of polarization are also subject to uncertainty because they come from the panel. So we can sort of assume that these estimates, they vary depending on how much the household was on. That's one way. Another way to do it is to kind of specify just textbook GLS regression where you allow for autocorrelation. So anyway, so it sort of allows for this more flexible variance covariance matrix. Either way, so bottom line is it does not change the main conclusions. And again, if you kind of combine those regression-based conclusions with just logical reasoning about home ownership being a hallmark of income class and transition matrices, it shouldn't be too surprising. Anyways, doing much better than I expected. Alrighty. So we can talk a little bit if you'd like. So all right. So yeah. So okay. So I guess here I could mention that, for example, we know that in American salaries are much higher, right? But they tend to exclude the benefits of public housing too, public education, public health. Therefore, if you include those, the differences might be less. So it's important to if you do cross-country comparison, you gotta have to do those things, especially for Australia. For all these conclusions are highly relevant for Australia, and this is kind of a freak country because there has been a freak of a swing and a freak of a country, and that's why all these IR they show up so strongly. So again, if you look, if there's some researchers, and this is kind of like one of those standard exercise, and particularly among PhD students, there's like millions of papers on measuring middle class. So it may not be disappearing, even if you see that it's disappearing. It's possible that the ratio, the relative importance of non-monetary components are changing, which misrepresenting the standards of living. So if you use, so this problem is particularly severe or misrepresenting, inequality of polarization when you use text data. Because if you use the stuff like SNF, where they have all the accurate measurement of the capital gains and all sorts of stuff, when you use the tax data, you only typically looking on taxable income. And imputed rents are just universally just ignored there. And there's even no way to construct them because there's no information housing. I guess one way you can say that, so in the paper I sort of discussed that, one way to work around this is, yes, if you do some sort of if you really want to respect this paper, this finding, then you should do the following thing. You should make sure that there's no housing swings. It's easy to check. You know, housing prices just interest to everyone, so they're just there. The second one is if you suspect an issue and you can't get IRs, then you should probably call your income a pre-housing disposable income. And that would kind of show you that, for example, for Australia, these income measures may misrepresent the quality of life, the quality of well-being, because it does not account for the fact that some people just, even those who are really doing well for themselves just have to pay, pay a lot of rent or whatever they pay to have a roof under their head. Okay, right. There's some tax implications which are, I really hope that people are not going to use that to increase taxes. But so you could speculate about taxes. So there's one paper that's by, probably your colleague. You probably know this guy. Anyways, he's my macroeconomist here at UNSW. I looked him up because his paper sort of in the same ballpark as my paper. No, I mean, IR is a bit of a niche thing, but his stuff is much better, because he's not, experimenting. So he's doing like life cycle model, and everything is very kind of serious. So, so he shows that, it's very common for Australians to, especially older Australians, to buy their home to pass the this income means test. Yeah. And so he also shows that if you kind of take it away, then there's going to be like higher income supply, which is like you're going to make old people work. So it's not a nice thing to do, I guess. So again, so if you remember, again, so another kind of tax implication, which is potentially can be sort of linked here, is that so 14, those who without IR are the poorest households, I actually might be not the poorest. They might be much better off from the actual standing of the economic well-being. So therefore, you probably it's not an optimal tax. So you kind of want to. But again, so my paper does not account for life cycle and dynamic incentives. So we don't really know what tax going to do. So it's very descriptive. My paper is descriptive, and this whole exercise is very descriptive. Yeah, just an earlier paper. So I have a paper. This is a strong statement, but so this is my earlier paper. This is sort of one chapter of my PhD dissertation. This is the other part. The first part I published when I was a PhD student this month. So when I put IR into income mobility measures, and I show that Australia again stands out. Again, just collectively, it kind of shows that, so far IR has been ignored because it doesn't change inequality. But if you kind of engage in a little bit more complex analysis of economic outcomes and opportunities, you'll see it does matter heaps.